Hey guys, hoping all is well with everybody. In this video, we're going to be talking about subtracting linear expressions. Now, instead of just jumping into some practice examples, what I really want to do in this video is model for you guys exactly what's going on when we're subtracting linear expressions. And I'd like to do that by this illustration. Let's say I have the expression 5x plus 4. And I want to subtract the expression 2x plus 1. Now, for housekeeping and bookkeeping purposes, one of the first things that you can definitely do is go ahead, if a term itself does not have a sign in front of it, go ahead and put a plus, indicating that it is positive. Otherwise, it would be negative, but there'd be a minus sign in front of it. So if it doesn't have a sign, go ahead and put a plus sign in front of it. Okay, now I'm going to illustrate this with a model. So what I'm going to do here is I'm going to draw 5 boxes of x, representing 5x. Plus, I'm going to draw 4 boxes of 1, representing 4. Now, we have a 5x, and what we're trying to do here is combine the like terms of the two expressions that will allow us to come up with one simplified expression. So remember, the like terms are going to have the same variables present, and constants themselves are also like terms. So remember, in order to be a like term, they have to have the same variables, okay? And there is a second rule, and the rule is that the variables must be taken to the same power. But since these are all going to be linear expressions for right now, they're all going to be to the first power. So we don't have to worry about the second rule as much. But it is good to keep it in the back of your head as we keep going on further in algebra. Now, positive 5x and positive 2x are like terms. They have the same variables present in their term. So positive 5x minus a positive 2x, if I take away 2x, that will leave me with 3x. Likewise, if I have positive 4 and take away a positive 1, remember constants are like terms, positive 4 minus a positive 1 is a positive 3. So my simplified expression after taking the difference is 3x plus 3. Okay? Remember that our ultimate goal here when we're subtracting is to combine like terms to make one simpler expression. Okay? Let's look at another example. Let's say that I have 3x plus 7 minus x plus 5. Now, here's another thing that I want to introduce to you guys that will help with bookkeeping and housekeeping. Not only am I going to add the positive sign, but if a variable being x or whatever variable it is doesn't have a coefficient in front of it, and what I mean by that is the number that is directly connected to it. If it doesn't have one of those, feel free to put a 1 as its coefficient. Again, it helps with bookkeeping and keeping things organized. This will help make it a lot more simple when you're subtracting the coefficients themselves to simplify your like terms. So we have a positive 3x plus 7 minus a positive 1x plus 5. Let's model this again. We have positive 3x, so that'll be 3 boxes of x, plus 7 boxes of 1 representing 7. Okay, now if I have 3x and I take away a minus, if I subtract a positive 1x, that's going to leave me with 2x. If I take a positive 7 and subtract a positive 5, I take away 5, That leaves me with 2. So my final answer is going to be, when I combine the like terms again, I'm going to get 2x plus 2. Alright, let's look at another one that's a little bit trickier, but it follows the same idea. Let's look at this one. We have negative 4x plus 3 minus negative x minus 4. Now, again, let's be very careful here. One of the reasons, the first thing that you want to do is go ahead and put that one coefficient here. Here's why that helps. If you're ever having trouble determining your like terms, here's a trick that you can do. What I like to do when I'm trying to find my like terms is I like to draw arrows once I establish them. So we have 4x here and a negative 1x here. Remember, like terms have to have the same variables present. Alright, so we have a 4x and a negative 1x. The coefficients themselves don't determine like terms themselves, but when it comes to adding and subtracting, that is when their role is most important. But they don't have to be the same in order to make the two terms alike terms. Okay, so we draw the arrow to indicate those like terms, and then remember that constants themselves can also be like terms. They can be combined, alright? Now, one of the reasons that putting the negative 1 coefficient is very helpful here. We have a negative 4x, but we're subtracting a negative 1x. When we subtract a negative value, we're actually adding a positive of that value. So if we take a negative 4x and subtract negative 1x, that's like negative 4x plus 1x. That's going to give us a negative 3x. Likewise, if we take a positive 3 and subtract a negative 4, that is saying 3 minus a negative 4 is like 3 plus a positive 4. That's going to give us plus 7. So our final simplified expression, when combining the like terms, is going to be negative 3x plus 7. Okay? Alright, let's look at another one. Okay, this one we're going to be actually looking at a story problem. It says that the expression 8x plus 48.75 represents the total amount of money the soccer team earned from selling X t-shirts. Now, with story problems and word problems, one of the most beneficial things that you can do is, as soon as you take away from a verbal sentence something that you can put into a mathematical equation or expression, try to do so. So it says that the expression 8x plus 48.75. So I'm going to take that expression represents the total amount of money the soccer team earned from selling X t-shirts. That tells me right there what my X variable means. X is equal to the number of t-shirts sold. Okay. Now, it says, if the team had to pay 2x plus $24 in expenses, write an expression to represent their profit. Now, remember that profit is total minus expenses. We have already determined that this expression is our total from the X amount of t-shirts sold. So what we're going to do is subtract 2x plus 24. Okay. Now I can still represent this as a difference. It just has a little bit different in form, but it still shows that I'm taking away 2x plus 24 from the total. Now, what I can do here is, remember, go ahead and put your plus signs indicating these values are positive. I have a positive 8x minus a positive 2x. That's going to give me a positive 6x. And then 48.75 minus a positive 24 is a positive 24.75. And this is equal to the profit. Okay? So remember, total minus expenses equals profit. Okay? Now, what it says for part B, and this is our answer. This is the profit expression. So when X shirts are sold, this is the profit made. That being said, question B says, if the soccer team sold 54 t-shirts, what was their profit? Well, we've already determined that our X variable in this question is the number of t-shirts sold. So if we plug in X for a value, in this case 54 t-shirts, that will give us a profit value. So here's what you do. You're going to take positive 6, sub in 54 for X, then add 24.75. And again, this is going to equal the profit of 54 shirts sold. Okay. Okay. So 6 times, and then this is just an arithmetic now. So 6 times 54 is 324 plus 24.75. And when you follow the arithmetic here, the mathematical sum is 348.75. And because this is a unit of profit, it's going to be dollars. Okay? Okay, guys, again, if you guys have any questions, please never hesitate to contact or message me. If you guys have any special requests for any types of example problems, I'd be more than happy to do them for you. But again, please never hesitate to contact me. I hope this video helps you guys out, and I hope you guys have a great day. Thanks for watching. Bye.